Hey everyone, welcome to the last week of virtual online school. Kind of crazy year it's been, but winding up, and this will be the last video for online chemistry. This is going to be week 7. So congrats if you made it this far. You've been following along, staying on top of your work. Should be in good standing to pass the class and get credit for chemistry. Just to let you know, this is a molar map, and if we were in class in person, I would be teaching all these boxes. And stoichiometry is the same. It just gets more involved, more steps. In between each one of these boxes, we would have something written on what we use to get from one to the other. But since we're online, we are only concerned about the top 4 boxes. So we're only going to be learning how to go from mass to moles to mass. We're always going to be starting and ending in one of these top 4 boxes. So have that out and have that as a reference. This week, if we had more time, I was going to go over the 4C representative particles and Avogadro's number. But due to time constraints, we are just going to focus on limiting and excess reactants this week. What limiting and excess reactants are trying to determine what one is the limiting and what one is the excess reactant in a given problem. And just to put it into an example for you so you can understand, remember that the limiting and excess reactants are both reactants. It's both something that you start with. They're on the left-hand side of the yield sign or the arrow. Okay, these are the reactants, these are the products. So when we talk about limiting excess reactants, we're talking about the ones over here on the left. If you were to make cookies, two more important ingredients when you make cookies are chocolate chips and, let's say, sugar. I know there's more ingredients to that, but just to make it easy, we're going to stick with those two. Let's say you had enough chocolate chip to make 3 batches of cookies. You have enough sugar to make 1 batch of cookies. Now, both of those are ingredients or reactants in order to make cookies. So how many batches of cookies could you make if you have enough chocolate chips to make 3 batches of cookies and you have enough sugar to make 1 batch of cookies? Well, based on limiting excess reactant, you could only produce 1 batch of cookies because the amount of sugar would limit to how many cookie batches that you could actually make. You have enough chocolate chips to make 3, but when you only have enough sugar to make 1, you only can make 1 batch of cookies. The excess in that example would be the chocolate chips. So we're going to try to do the same thing, but we're going to actually put some numbers to it. And we are going to do an example with limiting and excess reactant. These problems will always be given 2 pieces of information. One about each reactant. That's a given, every problem. It's nothing that you need to calculate. They are given to you. In this case, it's 5 moles of magnesium sulfate, which is one reactant, and 8 moles of KCl, the other reactant. Now what we need to do is try to determine what one has excess and what one has limiting reactant. Step 1, we have to balance the chemical equation. So that means that we're going to have to put coefficients out in front to balance this. The only thing I see that's not balanced are the potassiums and the chlorines. Everything else is balanced. So if I put a 2 here, I now have 2 potassiums, 2 potassiums, 2 chlorines, 1 magnesium, 1 magnesium, 1 sulfur, 4 oxygen, 4 oxygen. So since everything else is balanced, those just become 1. So step 1 is balance the chemical equation, and we just did that. Step 2, it says find the limiting reactants by starting with each reactant. Right here's each reactant, and calculate the moles of one of the products. So we have 2 products here, MgCl2 and K2SO4. We just need to pick one. It really does not matter, but whatever one we choose, we have to go to it both times. So I'm just going to choose the MgCl2, but it really doesn't matter. No rhyme or reason. One's not easier than the other, it's the same. So we are going to use stoichiometry like we learned last week, and we are going to go from moles to moles. We're going to go from moles of a reactant to moles of a product, and this product we're going to go to is MgCl2. So if we start with 5 moles of MgSO4, we're going to use stoichiometry, so it's all over 1. And luckily for us, this is only going to be a one-step stoichiometry problem. Since we are starting in moles and going to moles of a product, it's just one step. If they were to give us how much of each reactant in grams, it would just be 2 steps. We'd go from grams of A to moles of A, then from moles of A to moles of B, and we'd be done. So in these limiting excess reactant problems, you always stop at moles of B. There's no need to go to grams of B. You can stop at moles of B. So the most these problems will be are 2 steps. So they're not too bad in that respect. So I'm going to go ahead and go from moles of this to moles of that. I'm going to use the balance coefficients. So I'm going to put MgSO4 on the bottom because they need to cancel. And I'm going to do MgCl2 up top. And these are going to be a 1-to-1 ratio, so moles cancel, and we're left with 5 moles of MgCl2. So what this is telling us is if we have, let's say, 5 cups of magnesium sulfate, we can make 5 batches of cookies. That's kind of what it's telling you. If we have 5 of this, we can make 5 of that. So now we have to say, if we have this much of the other product, how much can we produce? So a totally separate stoichiometry problem, but we're starting with the other reactant, which is 8 moles of KCl, the other reactant. 8 moles of KCl. Still a one-step problem because we're going to go from moles of KCl and we're going to go into moles of MgCl2. I have to do it to MgCl2 because that's what I want. That's what I did on the first one. I have to compare apples to apples. I couldn't go to a different product at this point. Once I chose what product I wanted to go to, I have to do the same for both. The ratio here is going to be 2 to 1. So this will be 1 over 2 because it's 2 in front of the KCl and 1 in front of the MgCl2. Moles of KCl cancel. 8 divided by 2 is 4 moles of MgCl2. Now remember, MgCl2 is a product. So when I ask what is the limiting reactant, don't just say something moles of MgCl2. MgCl2 is a product in this case. So in order to determine the limiting is the one that produced the least amount. Did magnesium sulfate produce the least amount, or did KCl produce the least amount? In this case, KCl is the limiting reactant because you only can make 4 batches of cookies. So this isn't the limiting reactant, remember. What you started with was. So we'd say KCl, limiting reactant. And in this case, the excess is the one that produced more, and that's going to be the MgSO4. We call that the excess, the one that we have extra of. So to determine the limiting, it's whatever one produces the least amount of moles of the product. How to determine the excess? It's the one that produces the most amount of moles of the product. And that's all we need to do for limiting excess reactants. We don't need to find out the moles of excess. I'm not going to do steps 3 and 4. Just if you can look at a chemical equation, balance it, take the given information about each reactant and determine limiting and excess, you're going to be in good shape for Objective 5 out of your notes here. So that's kind of it for Chem B here for you guys. I hope you guys all have a safe summer, and hopefully you guys do some fun, exciting things, and you come back and share them with me in the fall. I did miss seeing everybody face to face. Kind of boring talking to a cell phone, but it is what it is. And take care, and if you guys need anything, reach out to me and let me know. I should have grades posted. They're due this Friday at 10 p.m. So Saturday, Sunday, I should get all your grades in and posted for you guys. So take care and keep in touch.